Hello again. Now we know what machine learning is, its types, potential challenges. Let's look at performance measures of machine learning. How can we evaluate our machine learning model? Simple and easy approach is split your dataset into training and test data. Generally, 80 to 20 rate is preferred and successful. Actually, we will split our data to more parts, but this is a future topic, and for now, you should know that the training and test data should be different, separated. Also, training data should represent the test data. Best evaluating method is testing the model with unseen examples and calculate the error. It is called generalization error. What if your training error is low, but generalization error is high? Most probably it's an overfitting issue. You know how to deal with overfitting. Another important subject of evaluating the machine learning models is hyperparameter tuning and model selection. I want to give an example from our first book from Gerald. And let's think that. With some assumptions, you picked two models, but you are not sure which one is more suitable. Then what will you do? One approach is train both of them and compare. How can we choose the value of regularization hyperparameters? Okay, let's say you trained 100 different models using 100 different hyperparameters, and you found the best model and hyperparameters. But then after all these experiments in the production, you got an 15% error. What happened? What do you think? Most probably, we adapted the model and hyperparameters to produce the best model for a particular dataset. Okay, how can we solve this problem? Best method is using key-fold cross-validation to prevent this type of issues. For now, let's assume that key value is 5. So this is 5-fold cross-validation. Idea is simple. Split your data to train and test, but in each iteration, change the test data and use all data in test. By this way, you can test your model with unseen examples and all of your data. Because we take now a key as 5, we divided our data to 5 folds. One of them will be test data and others will be training data in each iteration. And in each iteration, test fold will be different. This is also a core interview questions for machine learning and data science related positions. You should know cross-validation very well. Okay, now we have a good method to evaluate our model. Let's make an example. Think the cat detector, cat classification example. Before going deeper, I should warn you, in this part, you should concentrate. You can pause the video and get your coffee. I will try to make you think. Okay, let's continue. In our example, we have totally 100 images, data for test. And 20 of them are cat images and others are, let's say, non-cat animals. Our model will try to predict each image. Result can be true or false. After an experiment, if I say your model predicted 90 images as true and 10 images as false, you can say that my model's accuracy is 90%. You can divide true score to total. Is it enough to evaluate the model? Let's think that your model is completely wrong and just classify everything as non-cats, in other words, others. Then accuracy score will be 80%. When you say 80% accuracy, it sounds so far so good, but it's wrong. Then we need some other measures to understand if the model is really successful or not. We need to know the direction of true and false. Cat means positive. Other animals, non-cats, mean negative in our example. Then I need to know if the prediction is true when the image is cat, in other words, image is positive, or if the prediction is true when the image is non-cat, negative. We need to know that. We need to know the direction of true and false. Therefore, firstly, we should see real label of each example and model's prediction. Like in this table, if real label and model's prediction are same, that means the prediction is true, like in the first two rows. When I say true, there are two possible scenarios, like in the first two rows. This is valid for also false scenarios. Be careful now. If my model predicts the data as positive, and if it is true, that means true positive like in the first row. If model predicts the data as negative, and if it is true, that means true negative like in the second row. If model predicts data as negative, as non-cat, but it is false, that means false negative like in the third row. And if model predicts data as positive as cat, but it is false, that means false positive like in the last row. And this table is a confusion matrix. Then we can understand the performance based on this matrix, and we will other measures from this matrix. As I said, the accuracy is not enough to understand the performance. Let's think the same example. If model predicts all images as other, accuracy will be 80% because there are 80 non-cat images in the test data. Now let's exercise and think one by one. We have 100 images, 20 of them are cats, 80 images are others. As you see, predicted cat value is 0, and 20 predictions of others actually cats. How many cats are detected by the model? Answer is 0, but the accuracy is 80%. Second question, how many cats are available in test data? 20. Then our hit rate, sensitivity, recall, they are all same, they are equals, is 0. Model couldn't detect any cat. Don't focus on the formula, just think that model classified all images as others and couldn't detect any cat, then recall is 0. Okay, another question. How many cats are classified as cats by the model? None of them. Then precision of our model is also undefined because 0 divided by 0. And the last question, how many cats are classified as other by the model? All of them, 20. Then miss rate is 100%. Model missed all cats. As you see, if someone says the accuracy of my model is 80%, you should not think that it is a success before asking precision and recall values. And precision or recall value are also not enough itself to understand the model. You will see the reason now. Let's make another mind exercise. You will understand everything in one picture at the end of this exercise. I added the formula of accuracy, precision, and recall measures at the bottom. You can look when you need. Okay, you obtained the confusion matrix after testing our model. As you see, we have again 100 images in our test dataset, and 20 of them are actually cats, and 80 of them are non-cats, others. However, in this case, our model predicted 30 cats and 70 others. If you just look at the cat prediction column, you can see that 16 of these 30 cats predictions are true because their actual label is also cat. However, 14 of them are misclassified because their actual label is other, but the model predicted them as cats. Second confusion matrix obtained from different model for the same test data. As you see, this model predicted 18 cats and 82 others. And 16 of these 18 cat predictions are actually cats, but 2 of them are not. Now let's compare these two results and we will understand the performance measures better by this exercise. First of all, let's look at the accuracy. You can change from the formulas at the bottom. By the way, blue ones are true as you understand and the reddish ones are false. For the first model, we have 16 plus 66 true predictions. In other words, we have 16 true positive and 66 true negative. Totally, we have 100 positive and negative data. Therefore, the accuracy will 82% for the first model. With the same logic and formula, the accuracy of the second model is 94%, yeah. In terms of only accuracy, we can say that second model is better. However, first one also is not too bad. That's not enough for us, so let's continue. Now, let's look at the recall scores of two models. As you see, recall is calculated by true positive and false negative values. For the first model, first confusion matrix, you can see that true positive value is 16 and the false negative value is 4. Then 16 divided by 20 gives us 80% recall for the first model. Since the true positive and false negative values of second confusion matrix are same with the first one, recall score of the second model is also same, 80%. As you see, sensitivity or recall of these two models are same. Then if you just look at their sensitivity, you can think that their performance is same. However, it is not. Their accuracy is not equal. Accuracy and recall are also not enough to express the performance of the models, because for this example, you can easily see that first model's false positive value is also quite high. When the numbers are bigger and complex, it will be very hard to see from a table. Therefore, these measures are quite beneficial to understand model success or where you fail. Lastly, let's look at the precision scores of the models. For the precision, we need to know true positive and false positive values. For the first model, as you see, we have 16 true positive and 14 false positive. Then our precision value is 53.3%. But if you look at the second model, second confusion matrix, because false positive value is 2, precision score of the second model is 88.8%. Now we can see the big picture of each model. For example, we can say that first model is not precise as much as the second one, and think that they are phishing classification models, phishing detection systems. And if you classify a legitimate website as phishing and your precision is nearly 50%, then your users will not count on your warnings. Of course, there are some other measures such as false positive rate, false negative rate, etc. Not to make a too long video, I will not make exercises for them, but you should search other measures and practice like that. Try to calculate each of them manually. It will be quite beneficial for you. Now, you can say there are so many metrics which are the best to describe the performance, or if there is a trade-off between metrics, which should I prefer? Generally, a harmonic mean of precision and recall F1 score is a good measure. Also, in details, it depends on the project. For example, for the phishing detection systems, ultimate goal is to minimize miss rate to provide, let's say, secure environment for the users. Miss rate, in other words, false negative rate, and you can say with this model and hyperparameters, false negative rate or miss rate is minimum. And this is more important for our project. That's why I choose this model and parameters. Other important issues are data mismatch situations. For example, you can train and test your model with browser screenshots, but if the product has the ability to upload mobile photos, then your model will probably crash after getting some mobile photos. Therefore, dividing your test data as validation and test is usually a good idea. Of course, both of them should be representative of product data. And last thing about evaluating machine learning, a no free lunch theorem from David Wolpert. It is simply that to decide what to discard or keep, you must make some assumptions. There is no free lunch. In machine learning, usually we have to make some assumptions. Of course, they are not completely random. If you want to classify 3 different image groups, of course, you can start to try classification models, which are usually successful in image-based tasks. Probably regression model will not perform better than them. Your assumptions should lean on something meaningful and reasonable, of course. Okay, that was a long road, but now we are at the end of this road. We learned a lot of stuff in these sections. I hope now you know what machine learning is, what are the capabilities of machine learning models, machine learning types, potential challenges, and performance measures. If you watch these videos from the beginning, you will remember challenge questions about the fundamentals of machine learning. Maybe you couldn't answer all, for some of them at the beginning, but now I hope you can answer all of them. Let's look at them again. They are basic questions. Don't worry if you don't have clear answers for all of them, but try to look at them and search on the internet for alternative answers. As you see, there are core 13 questions here. Before starting end-to-end machine learning project, you should be able to answer all. Okay, it was a long road, but we completed the fundamentals of machine learning part. Now we are ready to start end-to-end machine learning project. I will start from literature review, and we will see data collection, data processing, building machine learning models, testing. I will try to cover all important phases of machine learning pipeline. And I will use Python and PyCharm, so complete your installations, get ready, and we will see phishing detection project with machine learning.